Hello, welcome to the series of videos on C programming language. I am Rajendra. In this video, we will study about single dimension arrays. So, what is the plan? First, we'll look at the basic concept of array, then some syntax, then the declaration and initialization statements for array, then indexing, how to access the elements, individual elements of an array, then character arrays and their properties, and then a few working programs. So I made in 2022 by making use of Visual C a simple example program which I would share. And long back I used Turbo C 3.0 and made a small program at that point of time also. That video also somehow I could retrieve. So I will share that as well. Okay, so this is the plan for this video. Okay, so what is an array? An array is a collection of items of same data type in contiguous memory locations. And in addition to that, this collection is referred to by a single name. For example, here suppose I name an array like A, capital A, of 4 integers. Okay, 4 integers. And suppose size of an integer under the implementation is 4 bytes. So here item 0, item 1, item 2, item 3, it means these 4 integers. So first integer, second integer, third integer, fourth integer. So first integer will occupy byte number 0, 1, 2, 3. Second one would occupy 4th, 5th, 6th, 4th, 5th, 6th, 7th, and next one 8th, 9th, 10th, 11th, and next one 12th, 13th, 14th, 15th. This order may change depending on the endianness, but I will talk about it in some other video. So first integer, first 4 bytes, next 4 bytes, next 4 bytes, next 4 bytes in contiguous memory spaces, and the entire collection would be referred to as by name A. So if I say A, it means I am talking about all these 4 integers together. Okay, now the syntax is there are 3 basic variations of declaring an array: some data type, then the name, legal name in the scope, and this opening square bracket, size, closing square bracket, and semicolon. This is one possible legal way of declaring an array. Next one is data type, of course, of which data type you want to declare an array, then its name, as usual size, but at the time of declaration we can assign the values. So make use of assignment operator, opening brace, closing brace, semicolon, and between these two braces list of values delimited by comma, list of values. Okay, now so all the values in this list of values must be same as this data type. Okay, then third one is data type, then name, then opening and closing brackets, square brackets without anything written inside it, assignment operator, opening and closing braces, and semicolon. So what is the difference between these two? Here I had written size. So the requirement is this size must be same as the number of number of values in this list. Okay, here compiler deduces how many items would be there. So depending on the elements, number of elements in the list of values. Okay. Now a few points to note. Data type, these data types can be either built-in like int, float, double, char, unsigned char, long double, etc., or user defined like struct, that is structure, etc., or union. The name has to be legal, any legal name in this scope. In one of the videos I talked about scope, any legal name unique in this scope. Next one is this size. What is the size? Number of elements of data type in this array. and it has to be an integer constant at compile time. When you are compiling the program at that point of time, this size must be known, and it has to be an integer constant which is greater than 0. You cannot assign negative number or 0 or any real number or so. Even real number, if you are writing 5.0, this happens to be an integer, but it will be treated as a real number. So this is not allowed. So you have to have perfectly positive integer constant greater than 0 at the time of compilation. List of values, these are values are separated by comma. Number of values and size must be same. So if we are using this as second form, then the size must be same as number of values in this list. Number of values and size, and all values must be of same data type. This is the property of array in C, that all values must be of same data type. Or for example, if you have an array of integers, floats, and if you assign some value which is an integer, since all integers are real numbers also, so during assignment, instead of float you can write integer values also. Now let us see some examples. Here int ages 5 semicolon. What does this mean here? Here it means this: ages is an array of 5 integer elements, and initial values are not assigned, so they can be arbitrary values, or the compiler may assign as per the choice of the implementer. Here temperatures is an array of 4 floating point numbers, so these are the values separated by comma and closing brace semicolon. So temperature is an array of 4 floating point numbers. Now the next example, char str opening and closing brackets, double quotes, within double quotes A, B, C, D. So this is a character string. So it is an array of type character. Now what is happening here? Str is an array of characters of size 5. So size of this array would be 5. It means it will occupy 5 bytes in contiguous space, okay, in memory. First 4 bytes would be nothing but the characters, capital A, capital B, capital C, capital D, and 5th character would be null characters. Either you call it a null, NULL, or within single quotes \0. Okay, so these are a few examples. So now let us look at few working programs which I have written. What we have done here is we have declared one array named A1 of type integer or int of size 4. Okay, but we have not initialized any value. Now one thing important, when we want to access any element out of these 4 integers, so we need to provide one index. So here index value is 0. So limitation on index values is minimum index value would be 0, because counting begins from 0, and it will go up to, but not including the size. That is, legal index values for this array A1 would be 0, 1, 2 and 3. So what would happen if you exceed the range of index values? It depends on the compiler. Okay, so minimum index value is 0, maximum is 3 in this case, and moreover we have not initialized any value to any integer. We have not assigned any value. So in this response to this printf function, it should print arbitrary value. What arbitrary value would be printed? It depends on the compiler or the implementation. In this statement, I have initialized first integer to 10. So this will be, in response to this, value would be should be printed as 10, and again in response to this second integer, some arbitrary value would be printed. Here I have declared an array of size 3 of type integer, of course, and 3 values I have provided. So this is another way of initializing the values in one go. and this for loop would print all these three values. Here I have not provided any size, so compiler will deduce it from right hand side of the assignment operator. So and this for loop while loop would print all three values of this array f1. So let us check it by executing. Now you can see here, in response to this, some arbitrary value has been printed because it has not been initialized. In response to this, a1 has been printed as 10, first value is 10 because we initialized, and in response to this one a1, it is some arbitrary value, we don't know, 32,766. In response to this one, next one, this 10, 20 and 30, because we initialized all three values. In response to this, it prints three floating point numbers which we initialize. And if you remember, by default, C compiler in C programming language, by default it prints 6 digits after decimal point. That's why it is printing like this. Okay, now let us rerun this program and see. Now you can see here, in response to this, again it has printed some arbitrary value, and now you can see in response to this, it has printed now some different value which is different from the previous value. So what value compiler will system will assign to those locations which have not been initialized, we do not know. So don't rely on them. Whatever we initialize, it will be guaranteed. But for arbitrary values, we don't know what would be the value assigned by the compiler. What we have done here is we have declared one array A1 of type character of size 3. So first location has been initialized with capital A, next one with capital B, and last one as null character. So what is expected in this printf? It is supposed to print capital A, then capital B, and then it stops, no problem, and then new line character, of course. And this is a special form of printf and formatting string %s. It applies to only character arrays. It does not work with arrays of different data type, other data types. So here pay attention, we have not provided any index value, only the name of the array. Okay, name of the array means the address of the array. In case of character arrays, we need not to provide any index. So what it is supposed to do is it will start printing from the first index location, that is capital A, and it will keep on printing unless it encounters null character. So it will print capital A followed by capital B followed by null character, so it stops there. So it is supposed to do that. In this array, I have declared an array of size 10, and in any sequence, in any order, we can initialize the values. Now what I have done here is, in 9th location, that is index number 8, I have put one null character, in last character position capital Z, then first location capital A, 1 I have skipped, and at 2, index number 2, I have put capital C. And the same statement here, and number of, so it's other 5 locations, 6 locations I have skipped. So what it is supposed to do is it will start printing from capital A. The next location, whatever arbitrary character compiler has provided, it should print that, and followed by a capital C and so on, and it should keep on printing unless it encounters null character here. Capital Z, of course, it is not going to print. So what will happen? Okay, let us check what does it do by executing it. Now it has printed these two characters, capital A followed by capital B, absolutely no problem. Now here it started printing from capital A, it printed capital B, then it can encounter null character, absolutely no problem. But here what it has done is it has printed only capital A. Then it means next location, index number 1, it has assumed that it is null character. That is why it has not printed capital C. So arbitrary value it has not supplied. It has assumed that in case of character arrays, this under Ubuntu 22.04 GCC compiler assumes that wherever we have not provided the value of character in case of character arrays, it is assuming that it is null character. We can check it by rerunning the program. Again, it does the same thing. It means by default this particular compiler assumes null character in character arrays for those locations which have not been initialized with. Okay. Here I am using a Visual C++ 2022 compiler. I have declared here an array of characters size 10. Okay, so it occupies 10 bytes in memory. First location I have initialized with capital A, which is written here. Its ASCII code is 65, which is displayed here. The next location I have skipped. After that, third location, that is index number 2, it is capital B, and following locations I have skipped, not initialized, so it should take some arbitrary values. Then ninth location, that is index number 8, is null character, and the last index location, which is 9, that is the 10th location, capital Z. And this printf is supposed to print all the characters one after the other until unless it encounters null character in memory. So let me debug, that is start execution, and let me move it here and a bit of zooming. Now you can see here the first letter it has printed is capital A. Okay, fine. Next one, it has printed some block character. So now you can see here capital A I have initialized it to, and capital B it has printed, and all those locations which I have not initialized, it has printed arbitrary characters. So same arbitrary character, its ASCII code is beyond 127. We used to call them block characters. So here Visual C++ 2022 assumes that whatever is the arbitrary character or whatever is not initialized in this particular case, to use this character. Now you can count here 1, 2, 3, 4, 5, 6. So like here, yeah, 1, 2, 3, 4, 5, 6, 7, 8. So total 8 characters it has printed, and ninth character. Now can you see here? It is the ninth character. Here, it has not printed anything. Okay, it has not printed anything. It means it stops printing as soon as it encounters null byte in the memory. Okay, so it depends on the compiler. If you happen to write your own C compiler, then you may decide to substitute the arbitrary characters as per your choice. Okay. Here I am using Turbo C++ 3.0, which was released in 1992. I have declared an array of size 10 of characters, of course. So first location I have initialized with capital A. Second location I have skipped, so it should fill it with some arbitrary or random value. Next location I have initialized with capital B, and the following locations I have skipped. And ninth location, that is index number 8, has been initialized with null character. So this printf statement, or rather function, it should start printing from first location, that is capital A, and it will keep on printing up until it encounters a null character in memory. So let me execute it by typing Control F9. So it has produced some output. Let me check. Now you can see here capital A, it has printed in top left corner. Now you can see here capital A, and then followed by some arbitrary character. So unlike Visual C++, it has used some heart character. Okay, and then followed by B, and all locations it has skipped. Okay, so what has happened? It has printed only 3 characters. First one is capital A, next one is heart character, next one is capital B. Now you can see here the third location onwards it has skipped. It means as soon as it encounters null character, before that it has not filled it with any character. It will be treated as null character, you can say. So if you happen to build your own C compiler, what you can do is you can assume whatever character you wish. In next video we will study arrays of higher dimensions. That is all in this video. Thanks for watching.